Okay, so this is a replacement video for the third video that didn't quite work at the end of the notes. If you haven't taken this notes down, go back and find that in the stream. I think where I left off was somewhere over here. So a quick recap. We have arithmetic sequences that travel by plus something, plus something, plus something. Even if that something is negative, like plus -5, plus -5, plus -5, it's going down, down, down. And we have geometric, which travels by multiplying, like times 2, times 2, times 2. Even if that something is a fraction, like times a half, times a half, times a half, it's still traveling by ratios and it's traveling geometrically. We have two function styles, recursive functions and explicit functions. Recursive ones have two pieces of information, the starting point and a rule to follow that relates a term value to a previous term value, and a rule thingy. Okay, so I left off somewhere over here. I was described the growing dots that were multiplying and multiplying and multiplying, and there's lots and lots of dots. At time 0, before any time had gone by, there were already 3. So when I get down to my explicit, f of n equals 3 times 2, start with 3, what do? I multiply by 2 a bunch of times. How many times? N times. How come not n minus 1 times? Because this was the 0 time. If this was a 1 here, then I would put a minus 1 here. Since there's a 0 there, I can put a minus 0 there. You don't have to adjust the n at all. The n is good for the number of times. The n is the same as the number of doubles, as the number of times is by twos and times is by twos is. That's because we started at 0 instead of at 1. When you start at 1, n is not quite right. There is one less times is by twos is times is by twos is, or in this case, pluses by twos is pluses by twos is. But, of course, when you subtract 0 from n, it doesn't change n, so you don't have to write that minus 0. But you could. Okay, and then I just calculated the 100th term. But 3 times 2 to the 100th power is like 3 bajillion million zillion. So I did this. This was going to be scientific notation, so it was going to be like times 10 to the 30th. Let's change this to a comma. You get the idea. It's a huge number. It's because when you multiply by something over and over and over and over and over and over, it gets very big.